Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to this video on medians and altitudes. And while a median can be an altitude and an altitude can be a median, they don't always have the same thing. Okay, so they all always going to go from a vertex of the triangle. So I'm going to draw an obtuse triangle here. And I'm going to draw a very similar obtuse triangle here. And I'm going to pick the same vertice on each one. Let me get a bright color. So if I'm doing a median, I need to go from here to the median or the middle of the other side. If I'm doing an altitude, think like altitude sickness or height, that's always going to be perpendicular to the far side. Now, that could be inside the triangle, could be outside. So I did obtuse triangles here, but let's look at an acute triangle. Okay. Not quite as similar as the last two. So the median, again, here's the middle, right? It's going to connect, and that might be the middle, eyeball in here, right? Whereas the altitude is going to drop straight down and be perpendicular to the base. So an altitude can occur outside of the triangle, but a median must be inside the triangle. And again, it splits it into two equivalent parts. Now, when your medians come together, we generally don't do our altitudes coming together, but we can. So remember, a median is vertex to midpoint. Okay? They will meet at something called a centroid. And that would be the centroid is your point of concurrency. If you don't know what a point of concurrency is, that's when several lines meet at the same spot. And it's interesting because it meets at a 1-to-2 ratio. What that means is, so ratios are a little different than like probability. So if this side were 5 units long, this side would be 10 units long. So that's what's meant by a 1-to-2 ratio, or this is a third of the line, this is 2/3 of the line. So that's kind of what we can think of there. Whereas the altitude connects a vertex to the opposite side, which might have to be extended at a right angle. This is called the orthocenter. Okay, the orthocenter can be inside the triangle, it can be outside the triangle, it can be like a lot of spots. So let's go ahead and we're going to get a triangle going. And we are going to look at the medians. All right, so I have this mirror. If you haven't seen the other videos, I don't like to have shiny side up because it gets really reflective, so I keep the reflective side down. This is just glue from where it fell off of its case, in case you were curious. And again, we're going to be drawing the medians here. Hopefully I am on straight. You know what? I can always extend my other line if I'm not, right? I'll fix that. There we go. Okay. I couldn't see what I was even worried about in the first place. So we'll put A, B, C here. Okay, so remember to find the median, the midpoint. You're going to, I'm just going to draw a bunch of circles. I'm keeping the same radius for all of them. Ooh, I might have needed a bigger radius. I think it's close enough I can tell. Well, back on here. Okay. So when I line these two up, I get this is the median, or the midpoint. When I line these two up, I get this is the midpoint. And it looks like I actually had it pretty good as the midpoint right there. Okay, so connecting B to the midpoint. Connecting C to the midpoint of the opposite side. Kind of doing these a little blind from my side so that it's easier to see on camera. And A to the midpoint. My straight edge is in the way of me looking. Okay, so they're meeting here. So that's what we're talking about as the 2/3 1 ratio, 2/3 to 1. That is double the length of that. So 2/3 of the line up here, 1/3 here. So 2/3, 1/3, 2/3, 1/3. So let's say they all met at point E. We'll pop D in here between B and C. So if A to E is 21, how long is E to D? So we're not talking the whole thing, but if you want to think about, so this is the double side, right? So AE to ED should have a 2:1 ratio. But AE is 21, and we're trying to find ED. So do you see how we've set up a proportion here? So we can do 2x equals 21, because cross product. So x is going to be 10.5. And if you wanted to know the whole length, you've got 31.5. So using the ratios, that's like using two fractions that are equal to each other, is a great way you can focus on this. There's some other ways you can approach it and things like that, but it really is good to know. So if you watched my video on angle bisectors and perpendicular bisectors, you would have found out that we had the incenter and the circumcenter. So we just expanded to that if you did the medians, that's going to lead you to the centroid. Okay, and that's going to generally be, well, that's always going to be inside the circle, and it's going to have a 1:2 ratio away from the vertex to the side. So keep that in mind, that 1:2 ratio is going to happen. And that's going to be per each median. And the altitude, again, that's not the right way of spelling. I'll draw the altitudes here in a second. But the altitude, again, is going to meet at an orthocenter. And aside from knowing the vocab word at my geometry level of teaching, I'm not going to go super deep into the orthocenter, but it does have some use in Euler's formulas and things like that. So mostly I just want my students to know that there are 4 different ways you could find the quote-unquote centers of the triangle: the incenter, the circumcenter, the centroid, and the orthocenter. So let's take a look at that orthocenter. And I'm going to make sure I don't do a right triangle. Okay, so remember it needs to be from this point perpendicular to the other side. And I'm going to kind of cheat so that we don't have to take a lot of time in this video. So we need just in the construction. So basically this is going to have to come through here, right? And it's going to need to slide over to where it comes to that point. So I'm going to extend this line, because a lot of times that's going to happen, right? And we've got to go through the point. We've got to be perpendicular to that line. I know I'm cheating by using something that has a 90-degree angle, but that's just saving us time on the construction. Okay, so there was that one, right? What about this one? So make sure we're perpendicular. Got to get through that point. There's our perpendicular, right? And then I still have to do this one. Make sure I get perpendicular through the point. Okay, so we had the one from here. We had this one here. And we had this one here. So that is what your orthocenter is going to be. And again, that's because our perpendicular, not perpendicular bisectors, but from a vertex to the perpendicular of the opposite side. So that's that orthocenter. And again, just knowing the vocab word is mostly what I'm going to be looking for in my class, because we just want to make sure that we know that we have 4 different ways we could do this. Okay, angle bisectors, give me the incenter, and it's going to be the circle is going to be inside the triangle. The radius of your circle is going to be perpendicular to the side of your triangle. The perpendicular bisectors, so that's different. These are not going through the vertex themselves, but the radius will be from the point of meeting, right? That's that point of concurrency to the vertex, and that'll give you the radius of a circle that just goes through the outside edges. And then the centroid, that's because we drew 3 medians. That's when it's a vertex. We connect the here we connect the vertex to the median, whereas here we had a perpendicular bisector. So that's the big difference, is that here it is perpendicular. Here it's perpendicular as well, but remember it's perpendicular to the opposite side, not necessarily a bisector. So kind of basically sliding this line over. Use each of them as the directions apply, but make sure that you understand that they do all have different uses. Your main beginning geometry uses are going to be these 3. These are fun to kind of draw a circle inside outside. This actually gives us some mathematical stuff that we can compare, knowing the 1-to-2 ratio.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.